So hopefully if anybody is absent, they can follow along with us. But 4.5, again, is a transformation. It's a non-rigid transformation. And we're going to go over these fairly quickly. So the lesson, well, first let me put my name on here. The lesson objective is very straightforward. Students will be able to describe and perform dilations in the coordinate plane.
Oh my God!
Okay, so we're going to start out with some vocabulary. A dilation is a transformation in which a figure is enlarged or reduced. So like I always tend to say like stretched or compressed, but the official words are enlarged or reduced. They all mean the same thing. Now the thing is, it's always respective to a fixed point C, and C is called the center of dilation. We also have what's called a scale factor, and that just means, we're calling it K, but it means if you're making it bigger, it's by this factor. So if you're making it twice as big, K is 2. If you're making it half as big, K is half. The scale factor is the ratio of the lengths of the corresponding sides. So now we get back into the polynomial corresponding sides of the image and pre-image. So here are 2 more words, image and pre-image, that are vocabulary, which we'll label this next picture. So let's say you have a dilation with center of dilation C, that's right here, and scale factor K. What it does is it maps every point P, PQR, in a figure so that P prime, every point P in a figure to P prime, so that the following are 2. So if P is right exactly on C, here's the first case, then these 2 things are equal. So there's no way to extend or enlarge just a plain point. Any other situation is where P is not equal to C. So P is not equal to C, then the image point P prime lies on C P prime. That's a ray. So it lies right on here. That means that this is what's called the pre-image, and you have to pay attention to that prime mark. Now, the scale factor K is a positive number such that K is equal to the image of the, the ratio of the image divided by the pre-image. Okay, and that's going to be our definition the whole time, and also angle measures are preserved. So if I have this one right here, PQR, and I enlarge it to P prime, R prime, Q prime, doing the red there, then K is going to equal P prime, Q prime. No, I'm only going to mark R, sorry. R prime, Q prime over RQ. K is also going to equal CR prime over CR. So again, we'll notice a couple of things. R and R prime angle has the same measurement. P and P prime angle has the same measurement. And Q has the same measurement. But when it comes to the sides, okay, I'm going to label a few of these sides. this is going to be 4 and 4. This will be 6. This will be 5. This is 12, and this is 10. So the way this is going to work out, you'll see, is that R prime, Q prime is 12, and regular RQ is 6. That means it's twice as big. C R prime goes all the way to here, and you'll notice that's 8 over CR, that's the original, which is also 2. So if it's K in any of this picture, K is always 2. It never changes. So you can find it one place and apply it to another place. And we have something else to show here. In this figure, right, we've got angle measurement preserved. We've got our scale factor positive. Now, in this picture, again, just because I marked that one up, PR, you may notice, PR and P prime are parallel. PQ and P prime Q prime is also parallel. And QR and Q prime R prime is also parallel. So you get a lot of things with that parallel from chapter 3. In addition, when the scale factor is greater than 1, so when K is bigger than 1, that's how you know that you have an enlargement. I always think of this as like greater than 100%, because 100% is equal as 1. But when K is less than 1 or less than 1%, then it is a reduction. So pay attention to those words. And if this helps you remember, great. So if it's less than 1, it's a reduction. If it's greater than 1, it's an enlargement. So here's 2 examples where you just have to look at the scale factor. We're going to tell if it's a reduction or an enlargement by looking here. From here to here is 12, from here to here is 8. And so all we have to do is figure out K, and K is going to equal CP prime over CP. Remember, because it's the image over the pre-image, and the pre-image is the original size. That's the one without the primes. So from C to P is 8, and from C to P prime is 12. Well, that's going to give me 3 over 2, and 3 over 2 is 1.5, which means this is an enlargement. It's going to get bigger, and you can see that it's getting bigger, but this is the same type of picture, and you don't know if it's getting bigger or smaller. All you know is that K is equal to CP prime over CP, and you'll notice CP prime is 18. That's the small one. So that's where you end up. You started with CP, which is 30. Okay, and we're going to reduce that to 3 over 5. And 3 over 5 is less than 1, so that's going to be a reduction. Should that work? Any questions? Pop your hand up. Let me know. Okay. Now, one of the things that we can do here is we can graph them, and we can do dilations right on the coordinate axes, which is really nice. Okay, so the next thing we're going to do is talk about that rule. If you have a point, any point xy, and it's the pre-image of a point, then its image after a dilation is always centered at the origin. Remember, at 0, 0. So it makes it really easy on a graph to just extend it, because if the scale factor is k, then the point P is simply kx, ky. You multiply them. Okay? So every point in the original pre-image is mapped onto the image, which is ky. So this is the pre-image, and this is the image. Okay? Now, there is one more thing that's in the book that's not in this explanation, and that is that if k is negative, because we only talked about positive, if k is negative, that means a 180 degree rotation. And that means about the center. So you're basically going to flip that. And what that does is it takes your xy's, whatever they are, and it just makes everything negative. Okay. So again, these are notes, but I'm going to show you how it works. First of all, what we're going to do is we're going to graph ABC with these vertices. And then the dilation with a scale factor of 2 is going to double it. So we'll start with A at 2, 1. And B is 4, 1. And C is 4, negative 1. So normally I would not try to eyeball it, but this is so small I'm going to. Okay. Now, in order to do the dilation with a scale factor of 2, A prime, you're just going to double that because it's going to be 2 times 2 and 2 times 1. You'll get 2 times 4 and 2 times 1. And for C prime, it's going to be 2 times as well. That's it. So then you put them on your graph. So A is 4, 2. B is 8, 2. It's B prime. And then C prime is 8, negative 2. Again, I would normally use a straight edge, but for right now, we'll just do that. Okay? And that's how you do it. You just multiply the numbers and boom, you got a graph. Now, if you have more than one transformation, like we did in chapter 4, then like this one, then we're going to do prime and then we'll do double prime. So for this one, we're going to graph FGH, triangle. So it's negative 4, negative 2. That's F. And then G is going to be negative 2, 4. And H is negative 2, negative 2. Okay. Drawing it as carefully as we can without a straight edge. Should have a straight edge. Okay. So there's FGH. Now, what I want to do, it's telling me that I want to graph the image after dilation with a scale factor of negative half. So first I'm going to do the half. And then I'll do the negative. Because they mean different things, right? So the first thing is I'll do F prime, which is half. So negative 2, negative 1. And then G is going to be negative 1, 2. And H prime is going to be negative 1, negative 1. Remember, because we're doing a dilation of a half. So F is negative 2, negative 1. That'll be F prime. G is negative 1, 2. Sorry, G prime. Oh, I shouldn't have put that there. And then negative 1 is right there. So there's F prime and H prime. So it's half. That's good. But now we'll do the negative. Because, again, that means a rotation. So it's a whole different transformation. So F double prime, it's just going to switch the signs is what it does. So F double prime will be 2, 1. G double prime will be 1, negative 2. And H double prime will be 1, 1. So 2, 1. Be F double prime. 1, negative 2 will be G double prime. And 1, 1 will be H double prime. So boom, boom, Boom. So see how it just flips it around or flips it around that way. We started with the black one. That's our pre-image. Then we did the dilation of 1/2, and then we flipped it for the negative. So again, hopefully this is coming back to you because you've seen it before. Now we're going to do some real life problems. If you need to go back, like I said, I will post this video later. So even though I'm going kind of fast now, you'll see what it is. You're making your own photo stickers. Your photo is 4 inches by 4 inches. The image on the stickers is 1.1 inches by 1.1 inches. Does this represent an enlargement or a reduction? And what is the scale factor? So the scale factor is what you started with. Your photo is what you start with. That goes on the bottom. You're changing it to 1.1. They're both inches, so I can leave them like that. Now what I'm going to do is change this to like a whole number, 1.1, so it's 1 1/10, so it's actually 11/40. That number is less than 1, which means it is a reduction. Okay. Number 5, you're using a magnifying glass that shows the image of an object that is 6 times the object's actual size. Determine the length of the image of the spider seen through the magnifying glass. So if you're seeing how big it is here and it's 6 times bigger in the glass, then this is going to be 1.5 centimeters times 6. It's going to be 9 centimeters, which is clearly larger than the original, and that is the answer to the question, the length of the image of the spider. So that's 1 and 2. Now, we're almost done here. We have 2 other types of dilations. And I'm actually, I'm not going to do these right now because you can actually do this on your own very easily. But this one, it takes numbers and it only affects the x. If it only affects the x, that's this way, right? So this is going to be called, this is a horizontal dilation where it only affects the x. And this one, as you'll see when you do the different color, this one affects only the y. See, there's the x just goes to x, but the y is changed. So this is a vertical dilation. Of course, they're getting smaller too because it's half. But what I want you to do in your notes is just write down the rules here. So again, if it is a stretch or a compression, if you start with xy, it's going to just, the rule will be the k will multiply, or your scale factor will multiply just the x. Okay, so again, it's a stretch, or you can call it elongation if k is greater than 1. That means your stretch factor is more than 100%. It is a compression if k is less than 1. Okay, so you can think of this as stretching further this way, or this shrinking that way. Stretch or shrink. And then a vertical one, again, you take all your x and y's, and you're only affecting the vertical. So now your scale factor is only multiplying the y. So you're going to stretch or elongate if k is greater than 1, and same rule, it's compression if 0 is less than k is less than 1. And because of these pictures here, it's going to be, so it'll stretch this way, or it will shrink this way.